Hello everyone. Today we are going to analyze this fixed beam. In this beam there are 2 point loads. Both of them are having the same magnitude 12 kilonewton. This load is acting at the distance of 2 meter from the point A and this load is acting at the distance of 4 meter from the point A. In this beam, we have symmetrical loading. The total length of the beam is 6 meter. Now we are going to find the moments MA and MB. For that, let us use moment area method. In the moment area method, first we have to draw the mu diagram. For drawing mu diagram, we have to convert this fixed beam into a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Now let us find the reactions RA and RB. Since the loading is symmetrical, we can easily find the vertical reactions RA and RB. For that, we have to add both of these two loads and then divide by 2. In this way, for RA and RB, we are getting 12 kilonewton. Now we have to draw the bending moment diagram for the simply supported beam. To get this ordinate, we have to multiply the vertical reaction RA with the distance 2. 12 into 2, we will get 24. Similarly, to get this ordinate, we have to multiply the vertical reaction RB with the distance 2. 12 into 2, here also we will get 24. We know that in the simply supported ends A and B, the bending moment is 0. We can connect all of the points and draw the bending moment diagram. This diagram is called the mu diagram. Now let us find the area of mu diagram. I have split the mu diagram into 3 parts. We have 2 equal triangles and we have a rectangle. Let us find the area of these 2 triangles. We know that both of them are equal, so we can find any one of the area and then multiply with 2. We know the area formula of a triangle, half into BH. Here the breadth is 2 and the height is 24. Now let us take the rectangle. We know the area formula of a rectangle, BH. Here the breadth is 2 and the height is 24. We can eliminate 2. 2 into 24, 48. 24 into 2, 48. 48 plus 48, we will get 96. Now let us draw mu dash diagram. We know that in this beam we have symmetrical loading. So the values of MA and MB will be same. The mu dash diagram will be a rectangle. Let us find the area of mu dash diagram. We know the formula for the area of a rectangle, BH. Here the breadth is 6 and the height is MA. So the area of mu dash diagram is 6 MA. Now let us equate the area of mu dash diagram and the area of mu diagram. We have found both of them. Let us apply them. Let us take 6 on the other side. It will come in the denominator. 96 upon 6, we will get 16. We know that the values of MA and MB will be same. So both of them are 16. But MA will be acting in the anti-clockwise direction and MB will be acting in the clockwise direction. We have found the fixed end moments. Now let us find the vertical reactions RA and RB. In this beam there is symmetrical loading, so we can easily find RA and RB. To find RA and RB, we have to add both of these two loads and then divide by 2. When we do that, we are getting RA and RB as 12 kilonewton. Now we are going to draw the shear force diagram. I am going to find the shear force values from the point A and towards the point B. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. Using that rule, we can find the shear force values. Here you can see the shear force diagram. Now let us combine mu diagram and mu dash diagram so that we will get the bending moment diagram. If we wanted to find the maximum positive bending moment, we have to find this height. 24 minus 16, we will get 8. Alternatively, we can draw the bending moment diagram by finding the bending moments separately for all the points. To find the bending moment values in the points A and C, we can use right hand side rule. Clockwise will be positive and anti-clockwise will be negative. Let us find the bending moment in the point A. In the point A, we have MA, which is acting in the anti-clockwise direction, so that it will be negative. Let us find the bending moment in the point C. MA is acting in the anti-clockwise direction, so that it will be negative. Or A is acting in the clockwise direction, so that it will be positive, and the distance is 2. Finally, for the bending moment at C, we are getting 8. To find the bending moments in the points B and D, we can use left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find the bending moment in the point B. In the point B, we have MB, which is acting in the clockwise direction, so that it will be negative. Or B is acting in the anti-clockwise direction, so that it will be positive, and the distance is 2. Finally, for the bending moment at D, we are getting 8. Using the values, we can make the bending moment diagram. You can follow any one of the method, whichever is easy for you. In these 2 points, the bending moment becomes 0. We can find the location of these 2 points. This diagram is symmetrical, so both of these 2 distances will have the same value. I am going to take this point and I am going to make a section in this point. You can see that I have made a section in this point. We know that in this point the bending moment is 0. Using the right hand side rule, we can find x, which is 1.33 meter. Let us apply that. Now we are going to end this session. Thank you for watching this video.